One. Hello, this is Brian Purdy with the Florida Aviation Network. Today we're at the Regional Air Cargo Carrier Association Conference in Scottsdale, Arizona. Today we're at Scottsdale's airport, and we're going to visit with the CEO and co-founder of Ampaire, Mr. Kevin Noertker. Welcome, Kevin. Do you like Scottsdale so far?
No, it's a great day for aviation as well.
Okay, great. Have you had a chance? Are you going to be able to go to the actual convention at all?
I'm staying out here with the airplane and helping people see firsthand this hybrid electric vehicle.
Okay. Now, is the static display just today, or is it tomorrow also?
Our static display is just for today. So we flew in from Los Angeles early this morning, and we're going to be flying back this evening.
Okay, great. Well, this is my first time here also, so it's turning out pretty nice. Too bad you didn't want to stick around a little bit longer.
Yeah, I know. It's all about timing, huh?
Always. Okay, so tell us a little bit about Ampaire. How long has this project been going on? It sounds like you've got multiple aircrafts now, and tell us a little bit about that.
Sure. So we kicked off Ampaire back in 2016 on this mission to decarbonize aviation by applying electric vehicle technologies into the aircraft. This has enabled us to take all that great technology that's electrifying ground transportation and bring some pretty massive benefits to aviation. So we're focused on hybrid electric propulsion systems, which prove out all that electric technology, but with safety and redundancy that people expect, as well as immense performance benefits like fuel savings of up to 50%, as well as full payload and range capacity for the vehicles.
Now this is a Cessna 337.
That's right.
It's multi-engine but centerline thrust. I can see that as being great for the test bed.
Yeah.
Are other aircraft that you're testing with also multi-engine?
So yeah, the Skymaster's been a phenomenal test bed. Twin engine, push-pull configuration, centerline is highly reliable and a great one to test new propulsion on. One of our launch products is going to be the Cessna Grand Caravan, which we're already flying hybrid electric. We flew last November of 2022 for the first time. That's a single engine plane. So one of the benefits of this is that our architecture is scalable across single, twins, and even planes that have more than 2 propulsion units on them.
So I think I remember reading on this one, you basically have one conventional and one electric motor?
That's correct. Yeah, on this plane we've got, it's a twin engine. One is fully electric, so up in the nose we've got a fully electric drivetrain with batteries in the belly pod, and in the aft we've got a combustion engine.
Okay, great. And does the combustion engine help recharge the batteries?
In this aircraft, they're separate. However, in the Cessna Grand Caravan hybrid that we're flying, you can use the combined system to recharge the batteries in flight.
Okay, so the Grand Caravan, that's a single engine. So is it not an electric engine then on that motor?
The Cessna Grand Caravan is a hybrid electric system. You'd call it an integrated hybrid electric, where you have a combustion engine half and an electric half that partner together to provide either the full peak power takeoff and climb, or the fraction of that power that's required for cruise. And that power optimization is really what drives immense fuel savings.
Okay, and I can see that's where the innovation is really having to come in to get that coordination between everything, computers, I suspect.
Absolutely. I mean, it's where all the secret sauce is in the optimization of the systems.
So I guess when push comes to shove, what kind of gain in efficiency or range are you getting from running in that dual configuration?
Yeah, so this is the beauty of hybrid electric, is that it's not compromising the performance. What we're seeing is that we're able to get the full payload capacity of this plane, plus you're saving half of your fuel burn on your average set of flights and up to 70% on your very short flights. So just think about that as far as an economic value proposition, in addition to the environmental benefits that brings. And then finally on the range, the longest that this plane has flown is 1,200 miles. I think it's probably capable of a lot more than that, and we're looking to demonstrate that sometime soon. But that just goes to show how broadly applicable these planes are. For example, we flew in this morning from Los Angeles here to Scottsdale. Tonight we're going to fly back. That's about 365 miles each way. So call it around 700 miles round trip. there are no charging plugs around here, and that's totally okay. Infrastructure independent hybrid can go anywhere you want it to go.
Sorry, are you topping off the tank before you go?
We are topping off the tank with fuel before we leave, yeah.
No reason not to be safe. Okay, great.
Yeah.
So it looks like you've got several sponsors. I think I saw something with AFWorks. Can you tell us about how many different type of backers that you have?
Sure. So every sticker that you see on the airplane is actually a story of people who are working together to bring novel innovation into this industry. So the first place that this plane was deployed was with Mokulele Airlines in Hawaii. So a group called Elemental Accelerator, which does clean tech and sustainability investments and support, helped fund a program where we were flying the EAS routes on the island of Maui from Kahului to Hana. So you'll see them on here. We also then deployed with some airlines in Scotland. So you'll see the tartan wingtips of the Highland and Islands Airport. We had two different programs going with the Future of Flight UKRI. This is a UK research program where they were investing in sustainable and advanced aviation technologies. We then brought the plane back and we flew to Oshkosh, and that was just a few years ago. And then most recently deployed the plane all the way up to Alaska in partnership with the Department of Energy. So you see some Alaska stickers on here. We're working with NASA, the United States Air Force, as well as the DOE on some continuing programs too.
That's great. You're going to give us a little walk around, so we'll let you take over the narration, and I'll just film as we go. Feel free to interject anything you think, hey, this is interesting and it's unique to us, and we'll go from there.
Sounds good.
Okay.
All right, Brian, so let me show you a little bit about the plane. So this is a really interesting aircraft architecture, originally a Cessna 337 Skymaster, kind of built originally in the 60s and 70s. These planes have been around a while. The configuration is really unique. You've got two engines that are both inline in the center of the aircraft, one up front and one in the back. Now that enables you to have redundancy and kind of simplicity in the controls of the plane, and is really why we decided to start aircraft type in particular. So having that redundancy in line allowed us to replace one of the two engines with a fully electric drivetrain and prove out that underlying technology, those building blocks that are enabling us to deliver electric and hybrid electric planes. In this particular airplane, we've got the electric system right here up front. So the electric system begins, with what's turning the propeller, right? Is an electric machine or a motor. That motor is sitting right here up front, and takes all of its input signal from a power electronics box that we call a controller or an inverter. That inverter takes the signal input from the pilot and tells the motor what to do, how much power to put in, how much torque to drive into that propeller. All that energy comes from lithium-ion batteries, which are in this plane in the belly pod underneath the fuselage.
I guess that's best for the center of gravity.
That's right. So this really balances the weight and balance of the plane. Putting the batteries there in the belly pod allows us to have the full cabin available for passengers.
Most times the electric motors are considerably smaller than the internal combustion. So you got the controller up front also taken out?
Oh, absolutely. This is mostly open air. Actually, the system itself is very, very volumetrically small and very dense. So the electric machine I mean, you can, if you poke your head in here, you could see the electric machine's diameter is not much bigger than the diameter of this cowling. So very efficient, very easy to package, and this is where we've both packaged the combustion engine, in this case in the back, electric in the front. We've done the reverse, so in one of our other Cessna Skymaster hybrids, we've done the combustion in the front, the electric in the back. We're upgrading yet again under a NASA contract to have a generator that's both propulsive and energy power generation in the aft of the aircraft. It's a really versatile plane that has been a phenomenal test bed for us.
I noticed it's still got some radiator things in here. Is that actually used, or is that for just heating and cooling of the cabin?
Yeah, we still use one of the 2 slots for the radiators here. It's important to have a good thermal system and make sure nothing overheats, and that's exactly what this is for. Given that this is deployed really all over the world, across the United States, as far west as Hawaii, as far east as the UK, as far north as Alaska and Fairbanks, really got to make sure it's able to operate in any of those environments.
Now, the trip to Hawaii, is that a single leg, or have to get there some other way?
So we island hopped when in Hawaii, but to get there we shipped the plane. One of the benefits of these high wing planes is that you can actually remove the wings and put it in a shipping container. That's how we got it to Hawaii. That's also how we sent it out to the UK.
Okay, great. Let's take a look at the inside of the control area.
Okay.
Cockpit. Notice you only got one seat up front.
That's right.
Experimental. I don't know whether it's, hey, we don't want anybody else up here.
Yeah, so I mean, we've had multiple pilot seats. For this case, especially out of the convenience and because it's usually just flown by a flight test pilot, just put the row of seats. So currently seats 4 out of the 6 original. The controls, our goal is to make it seamless for anybody who already knows how to fly one of these types of planes, to make a pilot interface which is as intuitive as the original plane that they flew with. So using similar levers, not adding significant additional complexity, making sure that the training is relatively accessible as any new type of aircraft training would need to be.
So are you running both engines at the same time?
Yeah, so during each phase of flight, we have a different balance of power between the combustion and electric systems.
I was just looking, at the mixture and the prop and stuff.
Mm-hmm.
Most multi-engineers used to moving them all at the same time.
That's right.
But you were saying, okay, we're trying to make it the same.
As similar as possible, yeah. So in this case, you have the levers for the combustion engine, just like you would in an original Skymaster, and then you have a lever for the propeller, the electric machine, and that's about how much power are you putting through that element.
Are you still moving them together, or?
We're operating each of those 2 independently. Okay. So like for example, you use full power in takeoff and climb on both systems, and then once you've achieved the altitude that you need, you'll throttle back one of the 2. Depending on the range of the flight and how much energy we've got and how much fuel we have, you balance the power between each. For this long leg here into Scottsdale today, we're mostly on combustion while cruising in, and then we'll use the electric and combustion for the takeoff and climb. Yeah.
You're going to give us a tour of the rest of the aircraft, or is there any significant... I can tell this is hybrid versus...
From the outside,
I don't see anything.
From the outside, it looks like just another airplane. In fact, from the inside, unless we've turned off that combustion engine, it feels almost identical to what you would expect the plane to be. The real impact happens in that 50% fuel savings, which is, while not immediately visible, certainly tangible for those who operate the planes.
I'm guessing it's half the sound on the ground with only one combustion engine, right?
Yeah, about 3 dB down. It's combustion engines are loud. The tips of the propellers, these are not optimized propellers for noise, and so there are a few areas where, of course, optimizing the combustion engine noise as well as the propeller tip noise will bring down the noise profile overall. One of the beauties of fully electric is that when you fly fully electric, and I remember when we were flying in California with our test pilot, we turned off the combustion engine. flying just electric, and it was quiet, wisping through the air, flying over the California beach line. It was glorious, and it's an experience I hope everybody can have someday.
That sort of begs the question, if, you know, how long will it last just on the batteries? Let's say your combustion engine went out and all you have is batteries as your reserve.
Yeah, so I mean, in that case, that's probably an emergency situation. Like an engine out is not something that you usually take lightly. So if we did lose an engine, you would be able to continue to power the electric system using the battery. Of course, it depends on how much battery you had left, or how much charge you had remaining. But you'd able to keep the plane in stable level flight, or climb if you needed. And certainly, I mean, this is a massive range extension from being zero engines. Be able to find a safe place to set the plane down. A likely flight to the nearest airport.
Now, fortunately, this being a test bed, you know, you're not going to be spending a lot more money on it to refine all those other things. You know, yeah, we got it to work, but that's as much as we're going to put on it for this.
Yeah, I mean, I think about it as an iterative process. So iterations, meaning taking incremental, thoughtful steps one at a time in order to achieve the big future you're building. So this plane has been upgraded like 4 or 5 times. We've upgraded the batteries, we've upgraded the power electronics, we've upgraded the motors, we've upgraded the displays and the software. And that's one of the important factors of being able to move quick, is the ability to do those iterative processes. One of the things I'm really proud of is our work with the Department of Energy through ARPA-E, our work with NASA, our work with the Air Force, where we're using our Skymaster test beds as just that, flying test beds for advanced technology, where we can take the cutting edge of batteries, electronics, and other components and bring those into flight much sooner than they otherwise would have been able to make. So in fact, we're upgrading these things pretty frequently here.
My mind wanders on things. Okay, let's say you've got a case, you've landed, they have no chargers or anything like that, and you wanted to top off the battery charge before you left. Would you be able to do that just on the combustion engine?
In the Cessna Grand Caravan, which we call the Eco Caravan, integrated parallel hybrid, it has that capability. So you are able to legitimately fly anywhere you wanted to go, and you would have as much reliability of being able to fly out of that as any other normal combustion airplane. And that's a really, really powerful unlock to make sure that we can truly serve all people, all routes, all communities, and not be limited by charging infrastructure or range anxiety.
Because that way, if we have the fuel, we charge the battery, shut down, top off the fuel, you're ready to go to your max speed. That's right. It's all the flexibility of a Toyota Prius or RAV4, isn't it? Oh, okay. Except I don't like Prius sometimes. Like, oh, I get great mileage in town, but I'm on the highway now. Yeah. I mean, it certainly depends on what you're doing. Much similarly, the Cessna Grand Caravan is going to get 70% fuel savings during takeoff and climb. Up to 70%. During cruise, you're probably only going to get 50%. So, right? Still phenomenal, transformative, and very impressive. But does depend on the phase of flight as to how much fuel you're really going to be saving. Okay, great. I guess the big question, like, why fly here? Why fly from LA to Scottsdale and then back again in the same day to go to the Regional Air Cargo Carriers Association? And the reason is because fundamentally I think it's important to be a company that does things, not just talks about doing things. A lot of people perceive these limitations on new technologies, limitations on charging infrastructure, battery weight, range, and payload capabilities. And I think it's on us to dispel those misconceptions, to show that it is not only possible someday, but it is happening already right now. And so whether it's flying to RACCA or going to Oshkosh or Sun and Fun or deploying in Hawaii or the Orkney Islands or making our way through the Canadian tundra up to Alaska, this is about doing and showing the future before most people believe it's even here. So I'm glad you're aggressive in showing this off. The more people that can see it, the more people that will want it, especially here with the cargo and the smaller aircraft. And it may actually go into the bigger aircraft.
That's right.
And you address sort of the disadvantaged or underserved airline areas where having, being able to do a round trip because you don't have all the services someplace is going to be very beneficial to everybody.
Absolutely.
Okay, great. Well, Kevin, thank you very much again. Let me get in. Once again, this is Brian Purdy with the Florida Aviation Network, live and in the clear from Scottsdale Airport, Scottsdale, Arizona, for the Regional Air Cargo Carrier Association Conference 2023. Have a great day.
Okay, guys, we're just on comm now. Can you read me?
Loud and clear.
Okay, good. We're out of the airspace, so just take us wherever we want to go.